All right, ladies and gentlemen, welcome back to our notes about areas. This is Mr. Sprangle here. We're going to be going over the notes today to find areas of regular polygons. Okay, so regular polygons, as we've mentioned many times this year, are polygons that have all congruent sides and all congruent angles. Okay, so the stuff we're going to be talking about today only applies to regular polygons. If it's not a regular polygon, you cannot use the following formulas we're about to talk about. But but let's start off before we get into this like new formula that's gonna like blow your guys' minds. First, we got to talk about what like a couple of definitions here. So the first thing we're going to talk about here is that a polygon is inscribed in a circle. So this is the key word, inscribed in a circle. And the circle is circumscribed about the polygon when each vertex, so each of these vertices, each vertex of these regular polygon lies on the circle. Oof, circle. Okay. So here, all of these regular polygons have vertices or vertexes, whatever, that lie on these circles. Okay. So these shapes are inscribed in the circle, and the circle is circumscribed about the polygon. Okay. So that's a first just like thing to get out of the way here. Okay. So the center of the polygon is, so all these are regular polygons, and all regular polygons can have a circle circumscribed about the polygon. That's the case for any regular polygon. You can draw a circle that goes through all the vertexes of the shape. So when we talk about the center of the polygon, we're really talking about the center of the circle. Okay. So in this case, the center is going to be about right about there. For this square, it's going to be right about this there. For this regular pentagon, it's going to be right about there. And then for this regular hexagon, it's going to be right about there. Okay. So all of these are the center of the regular polygons. Also the center of the circle. Okay. So that's that first piece. All right. Next, we have the radius. So the radius of a regular polygon. The radius, you may have heard this word before when it pertains to circles. Now, in a regular polygon, what the radius is just the distance from the center of the circle or the polygon to one of the vertices. So, for example, here, we actually have 3 radii. Okay. So the radius of a regular polygon is the distance from the center to a vertex. All right. So I want you guys to notice a little pattern here. So here we have a equilateral triangle, a regular triangle, and we were able to draw 3 radii. Here we have a regular quadrilateral, aka a square, and we can draw 4 different radii. Are you guys starting to see a pattern here? How many radii do you think this guy has? It's got 5, because it's got 5 sides, right? So draw them. Sorry, these aren't the straightest lines. 4, ooh, that one's real bad. 5, okay, radii. Cool. So and then this one would have 6. I guess I can draw them out. Okay, so that is the radius, okay? From the radius, we are able to come up with a central angle. So the central angle is just the angle formed by 2 radii drawn to two vertices. So basically it's just the angle formed between each of these radii. The central angle of a regular polygon is formed by two radii drawn to two vertices. Okay. Now, another thing I want you guys to notice. For this triangle, we have three central angles. For this square, we have 4 central angles. For this pentagon, we're going to have 5 central angles. I hope you guys are starting to see a pattern here, right? Yeah, the pattern is that the number of central angles is going to correspond to the number of sides the polygon has. All right, and then lastly, we have this new thing called the Apothem or Apothem. I am going to say Apothem because that's just what I say. I think it's actually Apothem, but you're going to have to just laugh at me throughout this video as I say Apothem. Okay, so the Apothem of a regular polygon is the distance from the center. So we're going to write in here distance. So distance from the center of the polygon to the side. Okay, cool. So if I were to, I can draw a whole bunch of these. I'm going to draw just a couple. So here, the apothem is going to be this. Okay. Now, something to notice about the apothem is that the apothem here is going to be perpendicular to the side. Okay, so it's the distance from the center to the side, but it's going to be perpendicular. Why is that? Well, at the very beginning of the year, we talked about the distance from a point to a line. And the shortest distance from a point to a line is the perpendicular line drawn between that point and the line. Okay, so that's just something, that's where the apothem comes from. Now, also, I think you'll notice here, if you look at this triangle, oh, it's not going to do it. If you look at this triangle here with the 2 radii here, it makes a isosceles triangle, right? Because these 2 sides here are both have a length of the radius, which means that the apothem also bisects that bottom side. Okay. Now you can draw apothems as long as it goes from the center to the side and it's perpendicular. You can draw as many apothems as you want. What do you guys think the maximum amount of apothems we could draw in each of these figures? How many apothems can we draw for this triangle? How many can we draw for the square? So for the triangle, we could draw 3. Makes sense. There are 3 sides. For the square, we can draw 4. Makes sense. There's 4 sides, right? So the number of apothems you're going to have is going to correspond to the number of sides it has. Maybe we should write here a note. I'm going to write a note here. The apothem is the perpendicular bisector. Oh dear, that's not a letter. Hold up a second. Perpendicular that's also terrible. It's a perpendicular bisector of the side. This is going to be hugely important later on when we start to find the area. Oh, my brother's calling me. So, we are going to get into that in just a second. All right. Next, we have the area of a regular polygon. All right, so all that vocab out of the way. Now we know what we're talking about. As we go through, I'm going to be using these terms like the center, the radius, central angle, apothem to explain how to find the areas of these regular polygons. So the big ticket item, the big thing I want you guys to get out of this lesson is right here. So the area of a regular polygon is this formula. So the area of a regular polygon is, the area is equal to 1/2 the apothem times the perimeter. This is the big ticket item. If you leave, just end the video now and all you get is this, I will be happy. Okay, you need to get this formula though. All right, so this formula is what is the main focus of what we're going to be talking about today. There's going to be a lot that goes into finding the apothem and the perimeter in order to find the area, but this is going to be the big thing I want you to get out of this lesson. All right, so we're going to find the area of each of these polygons here. So we're going to do a couple of examples to kind of test out this new formula. So find the area of each polygon. So first one we have is an equilateral triangle with an apothem of 8. Okay, so I'm going to draw it. Wow, perfect equilateral triangle. I'm going to draw the center of it, and I'm going to draw the apothem here. Boom, boom, boom. It's got an apothem of 8. Okay, great. Now what? Well, for these types of problems, you're always going to have to draw some lines. You're going to have to construct some different radiuses and apothems and whatever you need to do in order to figure out the apothem and the perimeter. So for us, we are going to have to draw a radius. So we're going to draw a radius, boom, right here. And I'm going to draw another radius because why not? Boom, boom, right there. All right. So, you know what? I will draw a third radius. Why not? Okay, cool. So there we go. So before we said that the central angle here of a regular polygon is the angle formed by 2 radii drawn to the vertices. So here in this picture, I'm going to actually erase this. In this picture, if I have all these radii drawn, what's going to be, first off, what's the angle measure if I were to go all the way around the circle here? Like all the way around, what is that? If you turn all the way around, how many degrees is that? That's right, 360. So it's 360 degrees all the way around. Now notice that it is, this whole 360 degrees is being divided into 3 different angles, right? We have an angle here, we have an angle here, and we have an angle here. So we got 3 different angles that we have to divide these 360 degrees into. So something I probably should have mentioned earlier, to find the central angle, to figure out what that central angle is, there's actually a formula for it. To find it, all you have to do is take 360 degrees and divide it by the number of sides the polygon has. So in this case, we're going to do 360 degrees, and we're going to divide it by 3. So when you divide that out, you end up with 120 as your individual angle measure. So here, this angle measure is going to be 120. All right, this angle measure is 120. They're all 120. Cool. All right, so these angles all are 120, which is good to know. Let's redraw that apothem. So when I redraw this apothem here, I know that has a length of 8. What is going to be this little angle measure right here? If you guess 60, you'd be right. Okay, because this apothem divides the central angle into 2 congruent angles. So now we have a 30, 60, 90 triangle. You could also think of it as the line from the center to here is going to cut the each of these angles in half, and all of these have to be 60 in order for it to be an equilateral triangle. All right, so we have a 30, 60, 90 triangle. Cool. So in order to find this last side, we have to use our special right triangle knowledge. So I'm going to draw myself a special right triangle. Cool, here we go. When we had a special right triangle, a 30, 60, 90 triangle, your smallest side was equal to x, your medium side is equal to x root 3, and your hypotenuse is equal to 2x. So here, in this case, we are given the small side. We are given the apothem, which is 8. So that means that my medium side here, so this bottom half, is going to be 8 root 3. Great. Now, I could do that same thing for this other triangle right here. If I know the apothem is 8, this is a 30, 60, 90 triangle, I could find that the distance from here to this vertex is going to also be 8 root 3. So then the entire bottom side there, if I were to add 8 root 3 plus 8 root 3, how many root 3s will we have? We will have 16 root 3. So if I'm using this formula, 1/2 area, or 1/2 apothem times perimeter, it's going to take the things I know. So in this case, I know the apothem has a length of 8 because it says right here. So 8 times the perimeter. In this case, each of my sides is 16 root 3. So I'm going to do 16 root 3 plus 16 root 3 plus 16 root 3. Add all those together. I'll write this down here, 16 root 3. 16 root 3. And 16 times 3 is going to give me 48. So I'm going to have 48 root 3. Cool. Let's simplify it. 1/2 times 8 is 4. 4 times 48 is 192. So it's going to be 192 root 3. Man. All right. So that's our answer. That's the area of a equilateral triangle that has an apothem of 8. Okay. Now, the reason that this is the case is because all we're really doing with this formula right here, all we're really doing is we're finding the area of each of these triangles. So like this triangle here, this triangle here, and this triangle here, and we're adding them up, which is kind of weird to think about. But if I were to take each 3 of these triangles and break them into their own individual triangles and find the area of each of them, it would work out. So for example, let's go down here, look at this demonstration. So here, the area, like in this, would just be the number of these triangles. So the triangles times the number of sides, right? So you figure out the area of the triangle and then you multiply it by, in this case, 6, right? Well, what's the area of each of these triangles? If we know that this bottom side has a length of S, and here this is the length of A, we can just use the area of a triangle, 1/2 base times height. In this case, your base is S and your height is A. So the area is just equal to 1/2 your base, which is S, times your height, which is A, times the number of triangles you have. Now, what I want you guys to notice that in this picture, if each of these sides have a length of S, what's going to be the whole perimeter? Well, it's going to be 1, 2, 3, 4, 5, 6. It's going to be 6S, right? So the perimeter really is just equal to the number of sides, or the length of the sides, times the number of sides. So I can take this S and this N and combine them into one variable P. So I can condense this formula into what we have before, just 1/2 area times perimeter. And that's what I'm hoping you guys will kind of see as we, get through a couple of these. Now that we kind of understand that, after you understand the reasoning behind it, you can just take the shortcut and just plug it into the formula, to be honest. But we need to know where it comes from, in order to be effective if we forget the formula at one point. And then in your book, there's a proof, theorem 11.6. It's in your book. I don't know. I can't remember what page it's on, but it also kind of, spells it out for you. Okay. So let's get back to the problems though. All right. So let's try the area of this polygon. So we have a square with a radius of 5. Radius of 5. So I'm going to draw multiple radii here. So we have 5 there. And I'm going to draw an apothem. So what type of triangle did I create here? Well, what would be the central angle measure? So I'll draw these radii. So what's this angle measure going to be? Well, we have 1, 2, 3, 4 of them. So 360 divided by 4 is going to give me 90. So all of these have a 90 degree, all these central angles are 90 degrees. Now, what if I cut that in half? What am I going to end up with? Well, I'm going to end up with 2 angles that are 45, which would make a 45, 45, 90 triangle. Sweet. So we can use what we know about 45, 45, 90 triangles to help us figure out the rest of this problem. So we know we have in this case, our hypotenuse is 5. The radius here is 5, so it's our hypotenuse in this case. So we got to figure out these missing sides. Now, before, when we did these, we remembered that special right triangles have a pattern of x, x, and x root 2. So what we need to do is set 5 equal to x root 2. And now we got to solve this for x. So to do that, we divide both sides by root 2. These cancel out. And I have 5 over root 2 is equal to x. Oof, that doesn't look too good. So what I'm going to do is I'm going to make it look a little bit better, multiply the top and bottom by root 2. And what that does is it makes it look like this. 5 root 2 over 2. Oh, sweet. We don't have any root in the denominator. So we're good. So that's the length of our apothem, as well as this side right here. 5 root 2 over 2. Oof. Which means this little portion is also 5 root 2 over 2. So from here to here is 5 root 2 over 2. From here to here is 5 root 2 over 2. So if I were to combine 5 root 2 over 2 and 5 root 2 over 2, what that's going to turn into is a total of 5 root 2. Right? It's almost like a half plus a half gives you a whole. Same thing with this side. It's also 5 root 2. But let's get back to what they're asking for. So here they're asking for the area. Now, honestly, you could do the 1/2 apothem times perimeter, but in this case, since it's a square, why don't we just take this sides? So in this case, 5 root 2. We're just going to take 5 root 2, since that's the length of the side, and we're going to square it, because that's the area of a square. So when we do that, we end up with 25 times 2, which is 50. And that's the answer to that one. All right. So we only got a couple more examples here, and these ones are a little bit tricky because, you have to, they just take a little bit because you have to, do the multiple parts multiple times. But once you get the hang of it, honestly, these go by really fast. So just make sure it's super important that you guys remember your special right triangles, especially, especially just knowing how to convert between the different sides and stuff like that. So here our radius is I'm just going to draw my special right triangle here. This is a 45, 45, 90 triangle since it's in the square. And so my 45, 45, 90 triangle follows this pattern. Okay. So if my hypotenuse is, so in this case, my hypotenuse is R, it's our radius, and our sides are A. So it's not that bad. So for this first one, we have our radius is 2 root 2. So that means that x is 2, right? That's hopefully pretty obvious right there. So that means that my other side is also 2. So if this is 2 and this is 2, my whole side here's got a length of 4, which means all my sides have a length of 4. Multiply that by 4, and you get 16. So then, to find the area, it's just 1/2 the apothem times perimeter. So 1/2 of 2 is 1. 1 times 16 is just 16. Okay. Let's try it again. So we're going to try it again with some different numbers. Now this time we are going to be given the apothem. So I'm going to erase this. Okay. So this time we are given, I'll use a different color now. Okay, so this time we are given the apothem. So this time this is equal to root 3. Okay. So if that's equal to root 3, so my x in this case is equal to root 3, that means my r here is going to be equal to root 3 times root 2, which we can just rewrite this as root 3 or root 3 times 2, which is the same thing as root 6. So we're just going to write root 6 right in here. All right. So if that side's root 3, then this side's also root 3, which means this side's root 3. And the whole entire side of the square is equal to 2 root 3. You have to add those together, get 2 root 3. We have 4 of those sides, so 4 times that is going to give me 8 root 3. And the area is equal to, in this case, you know what? I'm going to use 1/2 the apothem times a perimeter. So the apothem is root 3, and the perimeter is 8 root 3. So I'm going to do 1/2 times 8. It's going to give me 4 times root 3 times root 3 is going to give me 3. 4 times 3 is going to give me 12. Cool. All right. Last one here for this example. I'll do brown. So now this time we are given the area, which is interesting. So let's try to figure this out based on knowing the area. So we could say that the area is equal to, well, there's a couple ways to think of it. For me, the easiest way that I would think about this one is, what does that mean? So what are some formulas to find, the area of a square? You could do the side squared, or you could do 1/2 apothem times perimeter. I'm personally going to use the side squared one, right? So if I know my area is 100, that means each side of the square has got to be 10, right? Because 10 times 10 is 100. which means my perimeter is going to be 40. And my apothem is actually going to be half of that. You can kind of see visually here, the apothem is half of that side. Also, if this side's 10, you know, half and half, it's going to be 5 and 5. So my apothem here is going to be 5. Then if my apothem's 5, I just follow the 45, 45, 90 triangle, and I know that my radius is going to be 5 root 2. Okay. So that's a lot of stuff, doing a lot of different things here. It's very vitally important that you guys get good at these 45, 45, 90 triangles and these, you know, 30, 60, 90 triangles that we're going to get to in a second. So you need to practice those before you even try to attempt this stuff. All right, moving on. So now we're going to do it on an equilateral triangle. We kind of did this before up above, but we're going to try it again. Actually, we did. No, okay, we did not do this exact one. All right, cool. So here we are given that the radius is 8, but over on the side here, I'm going to draw a special right triangle so that we have it all. Do it in this color. So okay, so this angle here is going to be 30, and this angle up here is 60. So sussing it out, my small side is always equal to x, my hypotenuse is equal to 2x, and then my medium side is always kind of like the ugliest. It's going to be x root 3. So let's check it out. For this first one, we are given the radius. So we're given that this is equal to 8. So up here, this first one's equal to 8. That means my small side, the apothem, is going to be half of that, which is 4. Now here, that means that if this is 4, this bottom side's got to be 4 root 3, which means this is 4 root 3, and the entire side is going to be 8 root 3. So for my perimeter, I take the length of the side, which is 8 root 3, multiply it by the number of sides, which is 1, 2, 3, and you are going to get your perimeter. So 3 times 8 is 24. So it's going to be 24 root 3. Okay. Then we can take the apothem perimeter, plug it into the formula. 1/2 the apothem, which is 4, times the perimeter, which is 24. 1/2 of 4 is 2. 2 times 24 is 48. So it's going to be 48 root 3. Nice. Okay. Let's talk about, let's do the next one. So I'm going to erase these real quick. Ooh, that's not erase. There we go. So we're going to erase these real quick, and we're going to put in the new stuff. The part B here. That's good. That's good to go. Okay, cool. So let's do the new stuff. All right, so for this next one, we are given the perimeter is equal to 6 root 3. So that means all 3 of these sides added up have to be equal to 6 root 3. So to find the length of one side, I got to take this and divide it by how many sides there are, which is 3. So 6 divided by root 3, that means the whole side is going to be equal to 2 root 3. Right? So if this is 2 root 3, this is 2 root 3, this is 2 root 3. If I add all the 2 root 3s up, I'm going to get 6 root 3. Cool. So if this is 2 root 3, that means that this side, the apothem divides that in half. So each of these are going to be root 3. And then I just follow this pattern, right? My medium side here is equal to root 3. So that means my x in front of this root 3 is really a 1. So I know my apothem is equal to 1. So if my apothem is equal to 1, then that means my radius is equal to 2. All right, and then we're good to solve for the area. So for the area here, we're going to use a formula just as we did before. 1/2 the apothem, which is 1, times the perimeter, which is 6√3. So 1/2 times 1 is still a half. So a half times 3 or 6 is 3. So I'm going to end up with 3√3 as my area. All right. Cool. Let's move on. So we got one more. I'm going to erase all this. All right, so next we are going to be given the radius again. So it's going to be the same process as before. However, it's going to get just a little bit messier than before. So here we are given that our radius is equal to 3. All right. So if our radius, which is the hypotenuse in this case, is equal to 3, that means that half of 3 is going to be my apothem. So I'm going to write this as a decimal. It's going to be 1.5. So the apothem is equal to 1.5. All right. Which means that my last side here is going to be 1.5√3. Okay. That means this is also 1.5√3. So the whole side is going to be equal to 3√3. Okay. So let's so that's the whole side. Now, what is the perimeter? So that would be this side plus this side plus this side. All the sides are equal, so it's just 9√3. Okay. Then we got to plug it into the formula. This is not going to be pretty. I'm sorry, guys. So it's going to be 1/2 the apothem, which is 1.5, times the perimeter, which is 9√3. And we got to do it out. Okay. This is going to be, I'm going to have to bust out the calculator for this one. So 1/2 times 1.5 is 0.75. Multiply that by 9, and I end up with 6.75√3. And that is the area of that last one. All right, we're almost done. One more example. So for this last one here, now we have a hexagon. All right, so if we have a hexagon here, I'm going to draw the radii, all of them, because why not? So if I were to draw all 6 radii here, what's going to be the measure of this interior angle? Well, we got 6 sides, so it's just 360 over 6, which means that each of them is going to be equal to 60. If we cut that in half with the apothem, then this little side here is going to be equal to 30. Okay, and that one's 60. So I'm going to draw a little picture up here for myself. If I have a 30, 60, 90 triangle, my small side is always x, my medium side is x√3, and my hypotenuse is equal to 2x. So in this case, my radius is the 2x part. Half my side is my x, and x√3 is my apothem. All right, so A is equal to 4√3 in this case. So then that means that I'm going to erase this just so that we have it all. So a is equal to 4 root 3. So my radius is going to be equal to, actually, we're going to do that one last. So then if that's equal to 4 root 3, my small side has got to just be equal to 4. Which means my radius is equal to twice that. So that would be 8. All right. So we found half the side is 4. So this other half is also got to be 4. So the total side is going to have a length of 8. Now, how many sides do we have? So we have 1, 2, 3, 4, 5, 6. So you're going to take 8, multiply it by 6, and you're going to get a perimeter of 48. Now that we have the apothem and the perimeter, now we can start solving for the area. So the area is going to be equal to 1/2 the apothem times the perimeter. So the area is going to be equal to 2 times 48. So that is going to be 96, I believe. So 96 root 3 is your area. Cool. All right. So now we are going to find the last one here. So I'm going to erase this. All right. Okay. And we are going to use a different color. We're going to use this color. All right. So we are given the perimeter is equal to 24 root 3. So that means all these sides added up equal to 24 root 3. So to find the length of each of these sides, we got to take that and we have to divide it by the number of sides, which is 6. And we are going to be given that each side here is going to be equal to 24 divided by 6, which is 4 root 3. Okay. Then to find, this little side, we got to divide that by 2. So we're going to end up with 2 root 3 as this little side here. Okay, now this is where it gets a little hazy for you guys. So the little side is equal to 2 root 3. So in this picture here, I'm going to erase this stuff. So in this picture here, x is equal to 2 root 3. So in order to find the apothem, I have to take this thing that's equal to x, I have to plug it in for x right there, that x right there. So the apothem is going to be 2 root 3 times root 3. So 2 root 3. So to do this, you multiply the root 3's together. So root 3 times root 3 is going to give you just 3. So it's just going to be 2 times 3, which means your apothem is 6. All right. So that's the apothem. Now to find the radius, I'm going to take 2 root 3 again, which is my x, and I'm going to plug it into that x. So 2 times this stuff is just going to be 4 root 3. All right. Now to find the area. So the area, the formula is the same. 1/2 the apothem, which is 6, times the perimeter, which is just 24 root 3. Multiply that out. 3 times 24 is 72, so 72 root 3. Is the area of that second situation. Great. So I can't stress enough how pivotal it is for you guys to get very good at these 30, 60, 90 triangles and these 45, 45, 90 triangles. You have to get good at them because they're going to come up again and again. They're going to come up here a crap ton. And then in the future, when we talk about volume and finding different slant heights and stuff like that, you're going to need them some more. So please get good at these. I know nobody likes them, but once you get good at them, it's like, you know, you've unlocked the next level of your brain right here once you understand how the special right triangles work. All right. So then you guys have some classwork. You guys do it on your own or in your classes, whatever the situation is going to be. That's for you guys to do, but that is the note so far. So if you have any questions, please leave them in the comments below and I'll make sure I get back to them. Thank you guys so much and I will see you all in class. Bye.